Three identical spheres P, Q, R of weight W are arranged on smooth inclined surfaces as shown in figure. Determine the angle alpha which will prevent the arrangement from collapsing. These are three spheres of weight W and they are arranged with all contacting each other on inclined surfaces. Surfaces make angle alpha. We have to find out this angle alpha such that these spheres are stopped from collapsing. That is, if this contact point breaks before the angle for which these surfaces are inclined, say these surfaces are first horizontal and they are inclined slowly such that at what contact point they touch, that contact point we have to find out, or at what contact point these surfaces are made down such that the contact point breaks. So this contact point breaks at certain value of this angle made by the surfaces such that they are moving downwards. Surfaces are moving downwards such that at some value of angle alpha, the contact point between this point, at this point, it will break. It is called collapsing. These are sulfates. These are the contact points. These are the actions on contact points. And these are the reactions from the contact points. These are the reactions from contact points. First, from this triangle, we can see that it is equilateral triangle, and this angle is divided into two, and this angle will be 30 and 30. First, consider this sphere, and this is 30. This will be 180 minus 30 equal to 150 degrees. This is also same. Now, applying Lami's theorem at A, this W by sine of the angle between other two forces equal to sine 60, and R1 by sine of the angle between other two forces equal to sine 150 equal to R2 by sine of the angle between other two forces equal to sine 150. So, calculating for R1 and here we get R1 and R2 both equal because they have remainder as sine 150. So we get R1 equal to R2 equal to W into sine 150 divided by sine 60. We get R1 equal to R2 equal to W by root 3. So at no contact there will be gap, and this force will be 0 and this force will be 0. So now, considering this sphere, we know this angle. This is 90 degrees and this is 90 degrees. This will be 90 minus theta. This will be 90 minus theta, 90 minus alpha, and this is 90 degrees and this angle is alpha. So this horizontal angle is this vertical angle. Now, resolving, applying equilibrium conditions, that is summation fx equal to 0 and summation fy equal to 0. This r phi cos sorry, R5 sin alpha, it is directed towards positive x-axis. So R5 sin alpha directed towards positive x-axis. So equal to R5 sin alpha plus and R5 cos alpha. R5 cos alpha, it is directed towards positive y-axis. So plus R5 cos alpha and this force W directed towards negative y-axis. So minus W. So minus W and this force R3, it is directing towards negative x-axis. So minus R3. So and this R1 equal. So this is R1 cos 60 directed to negative x-axis. So minus R1 cos 60 degrees equal to and this R1 sin 60 degrees, it is directed towards negative y-axis. So minus R1 sin 60 degrees. So equal to 0 equal to substituting for R1 value, we get equation in R3. Substituting here for R1, we get equation in R5 and W. So it is R1 and it is R2. Now dividing 1 by 2. And when cylinders collapse, their contact point breaks down. So there is no contact and gap is created. So R3 equal to 0. Substituting R3 equal to 0. Here we get tan alpha equal to 1 by 3 root 3 and alpha we get 10.9 degrees. So at alpha value of 10.9 degrees, the system collapses. The contact point is established. Before alpha value of 10.9, they are in contact. So at 10, before 10.9, they are in contact. After 10.9, the gap is created. So before 10.9, contact is there, and after 10.9, contact is lost.